Our next video is about naming ionic compounds. Step 1, write the names of both ions, cation first. So again, the metal should go first. If your anion is one element, change the ending to IDE. So one element, change the ending to IDE. So chlorine becomes chloride. If it is a polyatomic, no change. Do not change the name of a polyatomic. Now, step 3 is the hardest step. This comes with practice. The more you practice it, the easier it gets. Is the cation found in groups 3 to the staircase? This means you're going to ask yourself this question. Literally, is your element, and I'm just drawing a makeshift periodic table here. It's asking you if your element falls where I just shaded in. Does your metal fall between groups 3 and the staircase? Okay, so how do you answer this? And this is just saying except one of those 6. Okay, so those 6 don't count. If the answer is yes, your metal does fall between 3 and the staircase, you must find the Roman numeral by using this equation. And this is one of those things that I have to do for you to really understand. So it's just the number of cations, which is the subscript of the cation, times x, this is your Roman numeral, plus the number of anions, subscript, times the anion's charge, equals 0. This equals 0 because the net charge of an ionic compound is 0. The positives must cancel out the negatives. If your answer is no, then you are done. Examples. Okay, just take it easy here. Take your time. If you don't get it, replay it. Come back the next day. Tell me that you don't understand it. Ask me specific questions about what's going on here. So, NaBr. Step 1, write the names of each thing. Na is sodium. Br is bromine. But step 2 tells you to change it to bromide. So, literally, you could be done right now. Because step 3 says, look at the metal, Na. Does Na fall between 3 and the staircase? No, you are done. This is your final answer. Next one, K2CO3. Now, when you have 3 or more elements, this means you have or contains a polyatomic. So you need to look on page 7 of your reference table. So if you don't have that out, pause the video and get it out. If it contains 3 or more elements, you need to spot where the polyatomic is. So for this one, K2CO3, we have CO3 here. Look on page 7 and you should see that on that list. So we're going to name the parts. K is potassium. CO3 is, look on page 7, carbonate. Okay, make sure you understand where that's coming from. Next step, potassium. Is it between 3 and the staircase? No. You are done. Okay, next, FeCl3. Fe, iron. Cl, chlorine, but we're going to change it to chloride. Step 3. Does your metal fall between 3 and the staircase? Yes, it's in group 8. So yes, it does. So then this is where the equation comes in. You have to do a little math to figure out a Roman numeral. So follow me here. You're going to look at the subscript of the metal. So in this case, is there a number there with iron? No, so that's 1x. So this first number is how many irons you have, plus how many of your nonmetal you have. So you look at the subscript of the nonmetal. So this is 3 times the charge of chlorine. We know the charge of chlorine because it's in group 17. Everything in group 17 is -1. All of this equals 0. So then, literally, algebra 1, pre-algebra problem here. So you just solve for x. So 1x plus 3 times -1 equals 0. So then x minus 3 equals 0. Add 3 to both sides. X equals 3. This becomes your Roman numeral. And there's your answer. Okay, next problem. FeSO3 2. Something should be going off in your brain telling you something at this point. How many atoms do we have? 3. Fe, S, and O. So this contains a polyatomic. Fe, iron. SO3 is sulfite. Okay. We okay so far? Iron and sulfite. Step 3, does your metal fall between 3 and the staircase? Yes. Now, we did just use iron and we got a 3. But the reason that we have to find the Roman numeral is because it can have different kinds of numbers. So you cannot just assume this one is 3 as well. So let's go through the math again here. Make sure you get this. How many irons do we have? 1. There's no subscript there, so 1 times x plus, okay, these polyatomics is what does it every single time to students. To find the number of polyatomics, you look on the number on the outside of the parentheses. If there are no parentheses with the polyatomics, then it is 1. So for a polyatomic, you look at the number outside the parentheses. So we're going to put a 2 times the charge of sulfite, which if you look on your reference table is -2, all equals 0. So x minus 4 equals 0. Add 4 to both sides. X equals 4. Now the question is, what's the Roman numeral for 4? V means 5. An I before V means subtract it. An I after means you add it. So 4 is IV. So iron 4 sulfite. Okay, last examples. Silver, or AgNO3. So Ag is silver. NO3 is nitrate. Because we have 3 capital letters, therefore we have a polyatomic. Next step, does silver fall between 3 and the staircase? Yes, but it is one of the exceptions. So therefore, you don't need a Roman numeral. If it's one of the 6 exceptions that we put on your reference table, then you don't need a Roman numeral. Okay, the next 2 are the most missed. I'm going to do the first one. You're going to do the next one by yourself and then check your answer. Cu, copper. CO3, carbonate. Okay, does your metal fall between 3 and the staircase? Yes, so now we do the math. How many coppers do you have? 1. There's no number there, so 1 times x plus, this is where people get it wrong. We have a polyatomic. Good hint here. Whenever you have a polyatomic and there's no parentheses there and you're trying to find the Roman numeral, put the parentheses. Do not touch or look at anything inside those parentheses to determine the Roman numeral. So how many carbonates do we have? We have just 1. That 3 is a part of 1 carbonate. So you look on the outside of the parentheses. So 1x plus 1 times the charge of carbonate, -2, equals 0. So now we get x minus 2 equals 0, so x equals 2. Now take a minute, pause the video, and try this one. Okay, PB is lead. SO3 is sulfite. Okay. Does lead fall between 3 and the staircase? Yes. So then we have to find the Roman numeral. So 2x, where's the 2 coming from? The fact that there are 2 leads. So 2x plus, how many SO3s do we have? 1. Polyatomic. Do not look at any numbers attached to the polyatomic. Look on the outside of the parentheses. So if there's not parentheses there, that means there's only 1. This is the most common mistake here. I'm telling you because I know. I even do it. I did it back when I was your age too. Make sure you get the parentheses around it so you don't get mistaken. The charge of SO3 on page 7, -2, equals 0. So 2x minus 2 equals 0. 2x equals 2, so x equals 1. Roman numeral of 1. Final answer. We will be doing more practice in class. You need to make sure you understand how to do this before we move on to the next topic, because it only gets harder if you can't get it. So please make every attempt to get my help or somebody's help in class. That's the purpose of this flipping of the classroom thing, is to get help on the actual practice piece. Now, what I want you to do is pause the video and try these 5, just somewhere on the side, down at the bottom, somewhere. Try these 5 on your own. When we come back in class, I will give you the answers and ask for any questions or comments. So please attempt these 5.